All right, we're on to video 5 here, going through questions 30 through 34, getting into the naming and writing of formulas, and also talking again about the ionic covalent properties. So let's start off with that, comparing those ionic and molecular compound properties. This is, again, is that table that I was talking about at the end of that previous video. So we want to talk about the simplest unit, the melting points, boiling points, and so forth. So I'm going to go back to that table that we've done before. We'll compare ionic here to covalent here. Let's break this down into parts. Boy, this is not a good table, but it'll work. And so here we've got the simplest unit. Let's do melting point, boiling point next. Let's do the strength of bond. Let's do it this way, bond strength. And then let's finish up with the common states of matter. So let's do all the ionics first. So the simplest unit, again, is going to be that formula unit. It's kind of an odd term. It's one, though, that we're going to use a lot in our second semester, especially the start of the semester. The melting points, boiling points, the ionic ones are really, really high. High melting points, boiling points. The bond strength is strong. And the most common state of matter, because again that melting points being high and the boiling points high, is actually going to be a solid. Those crystalline structures that we talked about before would best summarize the state of matter for ionic. All right, on the covalent side, we have the molecule as the simplest unit. The boiling points are going to be, and melting points are going to be low. Now, on the bond strength, remember that the bond strength within the molecule itself, intramolecular, is actually fairly high. It's strong. But if we're looking at those intermoleculars, those IMFs, those are the ones that are actually fairly weak. And we're going to get into more of that in second semester as well. And then the common state is actually going to be all of them, so solid, liquids, and gases. Okay? Make sure you know that. Again, we've stressed that a number of times throughout this semester, so it's probably going to show up again on the final. 31. What properties of ionic compounds indicate the strength of the bonds holding those particles together? And it kind of goes back to that previous question. It would be those high melting points and boiling points. Abbreviate those boiling points. It would be the fact that they're solids at room temperature. And their crystalline structures, that crystal lattice structure that holds it all together. 32. Now here's where we get into writing those formulas and naming the compounds. So write formulas for the following compounds. So the first question says, how do you know that these are ionic compounds? And we should be able to identify easily by the fact that it's a metal plus a nonmetal. It is a cation positive with a anion negative. So when we have those, we're just going to break that into two parts on each one of these. And we're going to write the formulas for both parts. So aluminum, and then it ends in 8, so that's a polyatomic, which is SO4. And then, like we've done in the past, we have to do those oxidation numbers. So we look them up, +3 for aluminum, -2 for sulfate. And then we cross them down. So it's going to be Al2. SO4 now, because that's a polyatomic, before I bring that 3 down, I'm going to put it in parentheses. Now again, remember the whole point of this, doing this, is to find the lowest numbers possible to make the overall compound neutral. That's a concept we haven't talked about in a number of weeks here, so just remember the compound is neutral. Therefore, this is the method that we can use to get it to that point in the lowest numbers possible. All right, then the next one, let's go to letter C down here. So we have barium, which is Ba, and hydroxide. Now, even though it's ide, it's a polyatomic, which is OH. And we do, again, because it's ionic, do those oxidation numbers, +2, and hydroxide's a -1, and then we cross them. Now, be careful. Hydroxide is the most commonly mistaked one where we forget to bring down, put parentheses around that before we bring that 2 down there, okay? And the final one, ammonium, is a polyatomic that actually begins because it's the positive, has a positive oxidation number, and that's with a +1. And then chloride, ide ending is just a single element, chlorine, and that's a -1. So 1 and 1 just ends up being 1 and 1. And I'm just going to cross off those oxidation numbers, because when you get final answers, those really shouldn't be present. They should be erased if you've put them in there in the first place. Okay, so there we go for ionic. All right, the next one, we're going to name the following compounds. And again, how do we know they're ionic? Metal and non-metal. Pretty obvious there. Okay, when we do this, we're going to separate the two parts again on each one of the problems. And on the ionic compounds, it's pretty easy. Just write the name of the first element, followed by, now if it's a single element, it's followed by the root, and then ends in "ide." Okay, so magnesium sulfide. The only thing that we also have to be worried about on this one is, does magnesium have multiple oxidation numbers? Because if it does, then we need to have a Roman numeral in our answer. Now in the case of magnesium, it's always just a +2, so there's no Roman numeral needed. Move on to the next. Okay, next one, name of the first element, barium. Followed by, is it a single element? Yes. So we put the root of that single element, followed by IDE. Take a look to make sure that barium doesn't have multiple oxidation numbers, and it doesn't. It's always just a +2. All right, and the final one here, we have copper as our first element. And that's followed by more than one element, so then that means that's a polyatomic, and all we do is we go look up the name of that polyatomic and write it down. So it's called sulfate for SO4. Final step is make sure that copper does not have multiple oxidation numbers, and when we look that one up in the gold packet, it does. It's either a +1 or a +2. So then what we want to do is we want to look at the sulfate side of things. So sulfate is a -2, and there's no parentheses here, so that means we just have one of those. So the overall negative charge is a -2. You only have one copper atom, so that one copper must be a +2, and therefore I will use a Roman numeral 2 for that one. Okay, question 34, our last one for this video. So it says name the following compounds or write the formulas for them. In this case, we're dealing with acidic compounds. So how do we know that these are acidic compounds? Well, in looking at the formulas, we can see that we have hydrogen. So if hydrogen is at the start of the formula, that is our tip-off for those acidic compounds. As far as when we have the name, we want to write the formulas. We're seeing things like hydro and ending in ic, or just an ending in ic, or also the ending in OUS. So if we see those kinds of endings, that is also our tip-off that we're dealing with acidic compounds. All right, so with those acids, what we do is we break off that hydrogen and we look at the second part. We look specifically at the ending of that second part, and in this case it ends in ic. So when you look at your rules, which are in the gold packet, nothing you need to memorize, if it ends in 8, then you just simply change the ending to ic. Now remember that sulfur was a little different. It's not just sulfic. We're going to end it as sulfuric. And then make sure that you put the simple part down, which is the acid part. All right, the next one, we take that hydrogen, and then we have the ending of ClO2. And ClO2 is the polyatomic that is chlorite. Okay, so if it's chlorite and it ends in ITE, then our rules say that we're going to have something that sounds just like that, but it's going to end in OUS. Okay, so we're going to take that chlorite and change it to chlorus, and then put the simple ending of acid at the end of that. Okay, and the last two. So I see that it starts off with hydro and it ends in ic. So now the rule says that if it starts with hydro, ends in ic, it is something that sounds like the stem that we have here, but it ends instead in ide. So that would be the element iodine, and then beginning with hydrogen. Now, acids are ionic in that we have to do those oxidation numbers crisscross. So I look up hydrogen, always a +1. I look up iodine, a -1. So this one simply is just HI, and I can erase those. All right, the next one is nitrous. So if it ends in us, then it's something like nitrite. So that would be hydrogen bonded to the polyatomic called nitrite, which is NO2. Again, look up oxidation numbers. The hydrogen's a +1 and the nitrite is a -1. So it's just simply 1 and 1. All right, that is the end of video 5, and we're getting closer to the end. We're going to move on to 6 soon.